Okay, time to move on to question 3. So question 3 says, does the line of regression estimate the sample data with at least a 95% confidence level? All right, so with question 3, we need to put, what we already know. We know the sample correlation coefficient is 0.546. What we need is the correlation coefficient critical value, because we're going to be drawing that illustration where the critical value serves as the boundary between the regions where we would consider the estimator to be good and the estimator to be bad. Okay. So you have to use custom programs that I've written for this purpose. So with Texas Instruments, we're going to need the sample size and also the significance level. Okay, so the sample size is 8 because we had 8 datums in our data set. Okay, we had 8 rows of data or 8 columns of data. So our sample size will be 8, and we're doing this to a 95% confidence level. And remember, oh, come on. Confidence level plus significance level is equal to 1. So if the confidence level is 0.95, then what does the significance level have to be? So it adds up to 1. Significance level has to be equal to 0.05. Okay, so that's where that comes from here. All right, so this is a custom program that I made for Texas Instruments. So hit Program, go down to R critical value, 83, enter. Enter again. Sample size is 8. Then the significance level is 0.05. And this is going to be two-tailed. And so we get a critical value of plus and minus 0.707, roughly. Okay, and you can see that's what I got there. With the NumWorks calculator, again, I can't just put this in. Instead, I created a MyOpenMath problem to do this. So this will be on your homework. This will be on your exam. If you're looking at a PDF of this, you should see this here, and you can click on it. And if you click on it, it will bring up this tab that looks like this. Okay, this is leftover information from a previous calculation, so I can hit try a similar question to make that go away. And I had a sample size of 8 and a significance level of 0.05. And if I hit submit, I get an answer of 0.707 or 70673. Okay. Yep. So that's our critical value. So now we draw this little handy schematic, which has a number line composed of correlation coefficient values between -1 and +1, and we put 0 in here as a reference. Okay, the critical values we just calculated were positive and negative 0.707. So we're going to have one boundary here at positive 0.707 and one boundary here at negative 0.707. And so the good regions are on the outsides. The bad region is in the middle. And so if we fill in what the correlation coefficient was of our sample, it's 0.546. And 0.546 is between 0 and 0.7. So it's going to be somewhere right about here, which firmly puts us in the bad estimator region. Okay, so our answer is that the line of regression that we calculated is a bad estimator of the sample data. Therefore, the line of regression should not be used to make estimations within the range of the X values. So if this were any normal analysis, you would stop here. You wouldn't go on any further, okay? But in this class, this is to learn something. So um, yeah, so at this point, one would stop. Um, Now, if we lowered the confidence level to 80%, okay, which means we'd have a significance level of 20%, then that would create a critical value of 0.507, and then this would be good. So a line of regression, we could say, is a good estimator, but at an 80% confidence level. You can kind of check that on your own, but if we change the confidence level, we could make it work. But we're actually trying to make it work at a 95% confidence level. So that's good. So for the purposes of the learning process, we're going to continue on to question 4. That's going to end this video. Let me know if you have any questions.